And we are live. Good morning, internet, or afternoon or evening, depending on where you are in the world. So my name is 0x Fisher, and today is Thursday, November 3rd, 2022. It's 10:30 in the morning in Western Europe, and we are doing a series on the Certified Kubernetes Application Developer exam, where I took a bunch of resources. I've gathered a bunch of resources from the internet with practice exercises and labs and stuff like that, and I will go through them one by one until I hopefully pass the exam. Okay, so I've done a bunch of those already. You can find them, I think you can find them on my Twitch VOD, but if you can't, because apparently Twitch is sort of limiting the I think they're limited in time now. You can only access them for 14 days or 7 days. I can't remember correctly off the top of my head. But I have backed them up on YouTube, so you can find them on YouTube. My handle is down below, as you can see in the banner. And so today we will be going through this one by, let me bump the font size so you can see, bmuschko, Benjamin Muschko. And apparently he did a course for O'Reilly, so this is legit, right? And it's got 429 stars, and it's been forked 343 times. It's a bit old. Last commit was done 2 years ago, but not too. Hold on, that was on June 22nd, 2021. Yeah, but you know, a year and a half ago. So yeah, we'll go through that. Just let me know if the sound is okay. Let me actually just check real quick, because I don't want to speak into the void. So let me be right back. All right, so I hope that the sound is good, because my device is set and I can see the levels, so I hope that we are getting sound. So anyway, I'm going to stop rambling now, and I'm going to get to it. So we'll crack on with the first one, core concepts. Okay. Oh, and also it shows the solution, so that's great. So create a namespace, CKAD Prep. As always, as I forgot to mention, I am on Minikube inside a Vagrant box running Ubuntu on my Mac. So I'm going to need to start Minikube. Minikube start, and Minikube add-ons enable ingress, just in case we need to create ingress resources. It's the ingress controller that comes pre-installed with Minikube. All right, so while this finishes, let's look at the lab. So create a namespace CKAD Prep. In the namespace CKAD Prep, create a new pod called myPod with the image nginx 235. Expose the port 80. Identify the cause. identify the issue with creating the container, write down the root cause of issue in a file name pod error.txt. All right, we'll do that. Change the image of the pod to 1.15.12, list the pod and ensure the container is running, log into the container and run the ls command, write down the output, log out the container. Okay, log out of the container, okay, yeah. Retrieve the IP address of the pod, my pod, run the temporary pod using the image busybox, shell into it and run wget command against the nginx pod using port 80. Render the logs of pod my pod and delete the pod and the namespace. All right, so we'll need the IP address because we'll try with the IP address and we'll try with the DNS name, and then delete the pod and the namespace. All right. Okay, we're good. So let's do that. So we need to create a namespace called CKAD Prep. So CKAD Prep. All right. In the namespace CKAD Prep, create a new pod called my pod with the image nginx. What's it called? krun and CKAD Prep. Actually, you know what? Let's config set context CKAD Prep, so we don't have to remember. Okay, so now we can do krun my pod image equals nginx 235 port 80. Of course, if we run the pods, error image pull, so if we do k describe pod my pod, we should look at the reason, state waiting, reason error image pull. Or maybe they want something else. Failed to pull, blah blah blah. Reason error image pull. I don't know if this is what they want or if we should get the reason failed. Do we have a reason? Another reason? No, yeah, let's grep for reason. Let's actually grep for failed rather. Yeah, we'll do that. We'll do k describe pod my pod, and then we'll do grep -i failed. All right, and then we'll send that over to temp pod error.txt. Yep. All right. Change the image of the pod to nginx. So k set image pod my pod nginx. Hold on. Let's first get the pod my pod -o YAML. Let's just verify something. The container name is my pod. Yep. So we'll do k set image pod my pod, and we'll do the container name called my pod, and we'll set the image to nginx 1.15.12. Is that yep, 1.15.12. All right. If we do k kubectl get pod image, what do you mean? Hang on, what? K get pod, k describe. What is going on? Successfully pulled image. Oh, it's running, which is weird. All right. Okay, so it's running. Log into the container and run the ls command. So that's easy enough. We can do k exec my pod it bash, I think, ls. All right, we can do that. We're not going to copy and paste manually. What we'll do is we'll do k exec my pod -- ls. Yep. And we will do bin temp pod ls.txt. I don't know. Write down the output, log out of the container. Yeah. Retrieve the IP address of the pod my pod. All right. So if you've seen my earlier streams, you'd have seen me have a lot of fun with awk and sed, trying to pull the IP address and extract the port number and everything else. So the way we're going to do this is we're going to do kget pods, my pod, right? And then we'll go no headers to strip the first line. Another way to do this would be to do, I believe, -head -n1. Nope. Hold on. Is it tail? Yep. Yep. So that would be tail -n1, and you'd get the same results. But we have the option here, so we'll use that instead. So kget pod, my pod, engine, blah. And so, we need to output we need the wide output, which will give us the IP address. Now we can count. So 1, 2, 3, 4, 5, 6. So we'll take that. We'll use arc to print the 6th column, not AWS, arc. Arc, and then we'll print column 6. We should get the IP address. Yep. Okay, so we've got the IP address, and so now we need to run a temporary pod using the image busybox, and we'll shell into it and run the wget command against the nginx pod using port 80. We'll do that in a one-liner. So we'll do krun busybox, krun temp, image equals busybox, and then we'll do it. Now we'll do rm --rm, and we'll do -it, and then we'll get the command. We'll do wget -o-, and we'll essentially get that IP. So we'll do kget pods my pod -o wide -- no headers. We'll pipe that to arc again, and we'll do print print $$6. Nope, just like that. We'll close this. If you use bash, command substitution is going to be with a $, but we use fish because we're civilized. Of course, I'm joking. All right, let's try that and see if. Let's do timeout. Actually, let's do timeout to -- timeout equals 2, and also restart never. 3, 2, 1. All right, no headers, not no header. 3, 2, 1. Argument 2 for timeout miss. Ugh, God. What do you mean missing unit in duration 2? Is it 2 seconds? All right, 2s. Yep. Yep. Good. We're good. And if we do pods, as you can see, the temp pod has been destroyed. And render the logs of pod my pod. Okay, logs, kubectl logs my pod. Boom. All right. I think there are more. Yeah, you can do. Yeah, so you can do p, and you can do since. So in since time. Of course, you can do tail. You can follow the logs like that. You can do k logs -f like you would tail -f. If you can do previous to. So you can get the pod, the logs of the previous pod if it's been restarted or destroyed, and then you can sort of return the logs near within a relative duration. So if you only want the logs from an hour ago, you can do that, and I believe that's it. Oh yeah, and then of course if you're in a multi-container pod, you can pass the -c flag to then get the logs for a particular container within that pod. All right, so delete the pod and the namespace. Well, that's easy enough. Okay, delete pod all enforce, and we'll go back to kconfig context default. We'll go back to the default namespace, and we will do k delete ns CKAD prep. And I believe this will completely destroy. And if you do this, I think if you just delete the namespace, it deletes all the resources associated with it. But I'm not entirely sure. All right, let's look at the solution. So, yep, create namespace. All right, create the pod in the new namespace. Yep, we didn't have to do this because we set the context to CKAD prep. So, just as a reminder. Kubectl get pod -n. So yeah, we get that image pull back off, blah blah blah. Go ahead and edit the list of events, can give you a deeper insight. All right, so you didn't copy anything. All right, go ahead and edit existing pod. So you could just use set image pod. Yep, that's what we did. That does exist. The pod should render the status to running. We did that. You can challenge the command and do this. Boom. So we did the ls thing. We retrieved the IP address. Okay. Image. So that's what we did. Oh, okay. All right. So he did it manually. So he essentially opened the shell and then he did it manually, but we just used a one-liner instead. The logs of the pod, so you can get the pod, and then we deleted the pod, and then we deleted the namespace. All right, so boom, that's 100% on this one. Configuration. Configure a pod to use a config map. Create a new file named config.txt with the following environment variables as key value pairs on each line. All right, so let's actually recreate that namespace. And let's set the context. So config set context, and we'll do CKAD prep, just so we can keep things tidy. Okay, so we'll do echo db URL equals localhost 3306. Can we do -n? Yep, I think we can do that. And then we'll do db username Postgres. Hold on. That's not the correct port, but Postgres. But hey, let's just do that. Nope. How do we render? Is there -n? I think so. No, it's not. How do we render new lines? Nope. Let's have a look. Render new lines. Echo. If you wonder about going, you get this output. Oh, it's -e. I knew it. Nope. What am I doing? Okay, so it's -e. All right, so we don't need that. We can just do this. Boom. I will send that to temp. Oops, not lost and found. We'll go temp config.txt. All right. Now what we need to do is create a config map named dbconfig. All right, create config map dbconfig. I think it's from file. It's gonna be temp config.txt. Yep. If we get cmdb config holy blah blah, we have that. So that's great. Create a pod named backend that uses the environment variables from the config map and runs the container with the image nginx. All right, so we'll do k run and temp. Oh, hello. No, it's backend. Okay, run backend. -- image equals nginx alpine. -- does it specify port? No, it does not. So we'll do dry run equals client. YAML. Do temp nginx.yaml. Actually, no, let's call it backend.yaml. All right. Let's open the file. Get rid of this. So we can do env from config map ref. and the name is dbconfig. We can exit. We can apply kubectl apply -f temp backend.yaml. All right, let's verify that it's running. Please. All right, it's running. So let's exec into it. Actually, no, that's shell to the shell to the bottom. Put on environment. Should define db. Okay. Yes. Okay. Exec backend. Please forgive the background noise if you are hearing a big truck. There's a big truck outside making a lot of noise. So please forgive me for this. Exec backend -it, and we'll do sh because we don't have bash, and we'll do env grep -idb. It's config.txt equals db url. Oh, hello, what? Hold on. Let me create cm help from file. Key file can be specified using its file path, in which case file base name will be used as config map key, or optionally the key and file path. Let's have a look. From file path to bar from file. Okay. All right. Well, let's have a look at the solution. So we did this. That's great. kubectl create blah blah blah. Okay. 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 All right. And if you do env, what? Why do I have config text equals this? That's a bit weird. What did I do wrong? Okay, create config map db config. Let's have a look at temp config text. This is weird. This is extremely weird. I don't know why. From file. Well, that's an enigma. Because the db username, we get the db username, right? So if we do that, we env, we have the username, right? But we get config.txt equals this. So maybe I've messed something up. But no, because, oh, it was from env file. But hang on, it should always be, I thought env file was for .env files. Well, that's interesting. All right. Oh, no. Oh. Boy. Yep, so it was from env file, not file. Okay, I get it. Well, that's fine. Moving on. Configuring a pod to use a secret. Right? Create a new secret called db credentials with key value pair db password equals password. Okay, so we'll do that. Okay, create secret generic db credentials. So db credentials from literal this time. db password equals password. All right, db password equals passwd. All right. Okay. Get secret db credentials -OYAML. Right, get this, and then we can base 64 decode. And we need to echo this, and then we need to do base 64-d. And then we get password. Create a pod named backend that defines, uses the secret as an environment variable named db and runs the container with the image underneath. All right, so we'll go back to this, and instead of this, we'll do env. So the name is going to be db password, the name of the environment variable, and then we'll take its value from a secret key ref. The key is going to be db password from the secret file name, the secret resource name db credentials. Right, so we'll delete pod backend, and we will recreate it. Hopefully it's running. So now we can do this. We can env and do grep for db. db password equals password. Brilliant. All right. Show to the pod and put out the environment variable, blah, blah, blah. Yep. So that's what we did. Cool. And value from secret key ref, blah, blah, blah. Show solution. Yep. Oh, no, that's not the... so yes, and a security context. All right, so create a pod named secured that uses image nginx for single container mount and empty the volume to the directory data app. Right, so okay, run secure image equals nginx alpine hyphen dry run equals client hyphen o yaml temp secure.yaml dim temp secure.yaml, and so we need empty their volume, so we'll do volume. God, get rid of this. Volumes. So the name is going to be secure volume. It's going to be an empty directory, and we will mount that under data app, and the name of the volume is secure volume. All right, get rid of this, and we will apply secure. Then we will, okay, so it's running. Files created on the volume should use the file system group ID 3000. Oh. Okay, so let's do secure, and then we'll do security context. I think it's run as a group 3000, but let me just sanity check. Let's do k explain pod spec containers security context. Yeah, let's do that. All right, run as group. Oh, run only root file system. Whether this container has read only root defaults. Note that this, no, so it's not that. It's not privileged. Allow privilege escalation, no. All right, so it's definitely run as group. Group 3000. All right. Get a shell to the running container and create a new file named list the contents of the directory and write them down. Okay, so get a shell to the running container. All right, so we'll do that. I don't think let's try that. I think we'll get an error, yeah. So we need to delete the pod secure, and we need to recreate it. And once we have a shell, we can do kexec secure it sh. Okay, write a file. Create a new file named log.txt. Right, attach data logs.txt. If I do ls-lah on data app, see the group is 3000. Cool. Okay. So that was that was this, and it was definitely, oh, hello, it's FS group. We didn't see that. Let's go back. There is nothing about FS group. Oh, okay. So, I know why. It's because so it's running as a different version. So this must have been renamed to run as group then, which is fine. And now, yeah, as you can see, we have the 3000 here. So that's great. Define the pod's resource requirement. Create a resource quota named apps under the namespace RQ demo using the following YAML definition in the RQ YAML. I will copy this. We're not going to bother with the namespace. We'll just create a resource quota directly. Right. Nope, that's not what I needed to paste. There we go. All right. In fact, we could have created it. I think we could have created it directly. We can do create quota, I think. Yeah. Yeah, we can set the limits there, just like that. Create a new pod that exceeds the limit of the resource quota requirements. Write down the error message. Okay, so it's CPU 2 and memory 500M. All right, so first we'll apply the resource quota. That, okay. And then what we will do is we will, I guess, delete the pod secure and we'll recreate it. And we will request CPU, we will request 3 CPU, and we will request total memory of 1 GI. Well, actually, no, let's just do 600 MI. And presumably, this is for exceeded quota, blah, 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 blah. So we'll do name, blah, blah, blah. Write down the error message. Okay, well, I don't know, we'll just go temp quota error dot log. Let's just do that. Temp quota error. What? Oh, I think it's standard error. Let's do this. Is it this? I think it's that. Yeah. Temp quota error dot log. Yep. Let's do this. Oh God, no. Let's go back and do that. But instead of doing this, we'll do 2. Because I think it's standard error. Okay, so now if I do cat this, boom. All right, we have it. Change the request limits to fulfill the requirements to ensure that the pod could be created successfully. Write down the output of the command that renders the used amount of resources for that namespace. What? Change the request limits to fulfill the requirements. Okay, so we'll go back and we'll do this. And instead of doing this, we'll do 1 CPU and we'll do 200 MI. Okay, to ensure the pod could be created. So write down the output of the command that renders the used amount of resources for the namespace. Write down the output of the command that renders the used amount of resources. I think it's top. I'm not sure about that. So we'll try and do this. Okay, let's look at the pod. Well, we are requesting 1 CPU and 200 MI. What are you on about? What? Let's just do CPU 0.5. And let's just quote that. Don't know why it's... Oh God, really? When creating temp secure, pod secure is forbidden. Exceed quota, app, requested, okay, used memory, limited. So what are you on about? I mean, I'm definitely below. I'm definitely below the threshold. So what's going on? Should I add limits? All right, let's just do limits then. Maybe that's the reason. So we'll limit to 1, and we'll limit that to 500 MI. Better work now. Ugh. Hey, do you know what? I'm giving up. So, create blah, blah, create a new pod. Okay, there's that. Scribe quota. All right, we have this. Next, create the YAML file. Blah, blah, blah. So 1 gig CPU. Okay, great. Blah, blee, blue. Yeah, well, that's what we did. And it did not work. So if we do k describe quota or app, I think it's called. So we're not using anything. So what are you on about? Oh, hold on. Let me delete this pod. Let's do that again. All right. And now if I go back and do this. Okay, it's not working. I don't know why. I have no idea why. I have no idea why. Oh. God. Let's do that. It wasn't. Fractional byte value is invalid, must be an integer, of course. So now I need to remove the quotes from all this. And now, presumably, this should work. Yes. Right, so it's not MI, it's M. Fine. Fine. Okay, user service account. Create a new service account name, backend team. Right, so K create SA backend team. All right. Print out the token for the service account in the YAML format. So I think it's K describe SA backend team. So the token is a secret, so we can go K get secret backend team token. Oops. Should it be generic now? We can just do that. Oh, YAML. Oops. Yep, and that's the token right there. It's base 64 encoded, of course. And that is going to be mounted in the pod. Print out token for the service account in YAML format. Okay. Create a pod named backend that uses the image nginx and the identity for running processes. All right. So let's just do temp backend. We can get rid of this because we don't need it. And I think it's service account. Nope. So it's here. Service account, backend team. Let's again sanity check. Explain this. Pod spec service account. Deprecated. Use service account name instead. All right. So you see, we did good. We can do this. Oh God! Let me just delete the bloody resource quota. Thank you. All right. Get a shell to the running container and print out the token of the service account. And because it's mounted, I think if I describe pod backend, mounts var run secrets this. So that's going to be the path that we can do k exec backend. If we cat this, token. Now we have the token. Cool. Let's look at this. Users again inspected. Blah 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 blah. Okay, so that's the secret. So that was the secret created. Then we can do that. Can print out token. Bleep blah blue. All right, that's what we did. Cool. That was for the configuration. Let's go back. Let's go back and multi-container pods. All right. Implementing the adapter pattern. The adapter pattern helps with providing a simplified, homogenized view of an application running within the container. For example, we could stand up another container that unifies the log output of the application container. As a result, other monitoring tools can rely on a standardized view of the log output without having to transform it into an expected format. Create a new pod in a YAML file named adapter.yaml. The pod declares two containers. The container app uses the image busybox and runs this command. The adapter container transformer uses the image busybox and runs this command. To strip the log output off the date for later consumption by a monitoring tool. Be aware that the logic does not handle corner cases automatically and would look different in the production system, right? Before creating a pod, define an empty dir volume. Mount the volume both containers within the path of var logs, of course. Create a pod, log in the container transformer. The current directory should continuously write a new file every 20 seconds. Now, we're not going to do 20 seconds. We'll do just 3 because we're not going to bother waiting 20 seconds for each new write. So we'll do that. We'll do k run adapter, and then we'll do image equals busybox. We'll do image busybox, and we'll do dry run equals client -o YAML, and we'll save that to adapter.yaml. So we'll do that, adapter.yaml, give it this. So now we need a volume called log volume. It's going to be an empty directory. All right. Okay, so the container app uses the image engine, so that's going to be called app. The container app using the busybox and runs this command. So we'll do this. Whoops, we'll do that. Copy this. There we go. And so we'll do command bin sh-c. Oops, nope. Hyphen C. And we'll copy this. All right. Okay, so that's the command for the first container. Of course, we need to mount this under var log, and it's going to be log volume. It's var logs. Okay, so var logs, blah blah blah. Great. And then we'll copy this bit. Actually, no, we'll take that. Put it here, and then we'll copy this bit. And this is going to be transformer. So the volume is going to be the same, and the command is going to be different. So it's still going to be bin sh -c, but this time we'll have that. And instead of sleeping for 20 seconds, we'll just sleep 3 because we can't be bothered. So we'll do sleep 3, sleep 3. All right. So okay, so both containers have the volume mount. Okay, it's done. Cool. Now we can just do temp adapter. Do pods. In fact, let me delete pod backend -- force, and let me do the same for secure. Okay. Crash loop back off. Why would that be? Describe pod adapter. Okay. think there's a problem with. It's definitely a problem with. What is going on? Crash loop, back off. Error. Which one? Let me just get the logs for adapter. Adapter-c app. Okay, so that's not the one. It's transformer then. Unexpected and the file expecting done. Did we not? Oh, we did not copy this bit. Yep. Done. Right, so let's delete the bloody thing. So actually, KDL adapter. KDL for kubectl delete. So we will recreate and delete. Would you please terminate? God. Force grace period equals 0. Yes, it's gone. Brilliant. All right, so let's do that. Okay, so it's creating and they're running. Cool. So now if we exec adapter -c transformer and do sh it for interactive and tty so var logs shouldn't be something like that. We watch ls var logs. Hold on, what? Okay, log into the current directory should continuously write a new file every 20 seconds. Oh yeah, it's disk space.c, so let's go back. Yeah, as you can see, it flickers, which means it's actually do cat watch. And let's actually watch cat var logs disk base.txt. See, 56, blah 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 blah. So it's adding new. So it's. Did we do 5 or 3 seconds? Can't remember. No, it was supposed to be. Oh, but okay. All right. But this one does it every 5 seconds. So it's the app container does every 5 seconds. But as you can see, yeah, it's every 5 seconds. It just appends to the disk space file. So that's good. Blah blah blue, blah blue. And then yeah. Cool. Moving on to number 4, observability. Ooh, this is going to be about, yeah, liveness probes and readiness probes. Create a new pod named hello with the image bottom at Node.js hello world that exposes the port 3000, providing a Node.js port for the container port. Oh, okay. So, run hello. Image is going to be Bono Mat. That's it. Let's copy it. But actually, let's copy the whole thing. Because why not? Fucking copy. right? And then we'll do dry run. Oh, yeah, no, we'll just do, let's just do port 3000 try run equals client hyphen YAML temp hello dot YAML temp hello dot YAML. Okay, so the port name is gonna be Node.js port. Yep. Alright, now we need to get rid of this, and we will add a readiness probe. I believe it's going to be HTTP GET. It checks the URL path, down the port reference with the name. After 2 second delay. Okay, well let's do path because it's path. So path is this, and then port. Can I do? Let's do k explain pod spec containers. So readiness probe dot http get dot port. Name all number of the port. Okay, so the port is going to be Node.js port. All right, so we can use either the name or the integer value. So that's great. And so what was the other thing? After 2 second delay, so that's going to be initial delay seconds of 2. You do not have to define the period interval. All right, that's cool. Add a liveness probe that verifies that the app is up and running every 8 seconds by checking the URL path and G on the port reference. The probe should start with a 5 second delay. All right, let's go back to that. We'll do liveness probe HTTP get path. It's going to be this. The port is going to be Node.js port, and the initial delay is going to be 5, and the period seconds is going to be 8. Is it every 8 seconds? Yep. Shell into the container and run G, write down the output, exit the container. All right, so we'll do temp hello. Let me delete pod adapter because we don't really need it. Okay, so is it running? It's still creating. Oh god, would you just? What is it doing? Is it pulling the image? Ugh. Yeah, it is pulling the image. I hope it doesn't take forever. Oh no, okay. So now we can kexec hello -it. Hopefully we have bash. We don't. What? Oh, it's -it. Alright, so if I do curl localhost 3000. Okay. So I guess that's that. And retrieves logs from the container and write down the output. Okay, logs, hello. Magic happens on port 3000. Okay. Alright. Yep. Da-da-da. Blah, bleep, blue. Okay. Fixing a misconfigured pod. Create a new pod with the following YAML. Follow logs are running and identify the issue. Fix the issue by shelling into the container after resolving it. Okay, well, something is up with this. So we'll do failing.yaml. We'll copy this. We'll apply. We'll delete pod hello force grace period equals 0. What's running? So, I mean, what the hell? No, I don't see any issue. I do not see an issue. All right, so let's just do k logs -f failing pod. Ooh, can't create root temp current directory, non-existent directory. It doesn't exist, so fix the issue after resolve the issue. The current date should be written to a file, render the output. All right. So temp k exec failing pod -it bash. We don't have bash, we have sh, and so now we can make their root temp. If I logs -f failing pod. Okay, and so it's cd temp. It's every 5 seconds. Hold on, does it? Current date.txt. Well, it should just create the file if it doesn't exist, so why? Alright, let's just do that then. Touch current date.txt. I don't know. It's just a bit weird that it would do that. What? Follow the logs of running container. Fix the issue by shilling it to the container. After resolving the issue, the current date should be written to a file, render the output. Yeah, but it's just not doing it. Do echo date, temp. Yeah, so it should essentially, it sleeps and does it for 5 seconds. It's just a bit weird that it doesn't do it. Let's just go back. Let's see the solution. Blah blah blah. Gates running. Runs the log of the container. All right. What? Hold on. Well, we have the temp directory here. Let's go temp. Yes, root temp. So we have the current date. Oh. Oh, it's working all along. Wow. Okay, well. I don't know what to say. Okay, so we got it right. So that's cool. Moving on to pod design. Defining and querying labels and annotations. Okay. Create 3 different pods with the names front-end, back-end, and database that use the image nginx. Okay, declare labels for those pods as follows. Okay, so let's just do that. K run front-end image equals nginx. Image equals nginx. Can we create a fish function for this? No, because it's too. Yeah, no, I'm gonna be short on time, so I'm gonna do krun from nginx, blah blah blah. We'll do alpine instead. Yeah, I'll do that. We'll do backend, and we'll do database. All right. Oh. Okay, delete pod all, of course. Let's go back. So front end labels is going to be env prod, so env equals prod and nope. What am I doing? team shiny, team equals shiny, and then for the backend we'll have env prod and team equals legacy, and it's going to be backend. All right, and the database, for the database we'll have this, and the team is going to be storage, and this is going to be database. All right, and if we do show labels, yep, we have the correct labels set. It's cool. Declare annotation for those pods as follows. So okay, and then backend. So we'll do okay, annotate pods backend. No, it's front end. Front end. Contact equals John Doe. Commit equals this. All right. And then we'll annotate the backend. Mary Harris. So actually, let's do Mary Harris. And it's going to be backend. So the backend, boom. And if we do k-describe a pod front end, and then we'll grep -i -a3. Let's do 5 lines. Annotation. Yep. Okay, cool. Let's do the same thing with backend just to verify that we have the correct annotation. So backend, and we have the correct annotation. Cool. Render the list of pods and their labels. We've done now with show labels. Use label select on the command line to query for all production pods that belong to the teams shiny and legacy. All right, so we'll do k get pods -l -l and equals prod. All right, so we've got that. Can we do show labels? Yep. And then we want the team to be, and I think it's going to be either legacy, shiny, what was it? Shiny and legacy. I hope this is, yeah. Name cannot be specified, so we'll do name cannot be profiled. Let's do that now. All right, let's just try and do that first. Yeah, so that's not. Can I do L again? Okay. So now I can do shiny and legacy, and hopefully this works. Nope. Well, no, there is I don't have it. Hang on. Okay, get pause, help. Show label, yeah, blah blah blah. Selector. Match to the filter on. Select this. Key 1 equals value 1. Matching objects. File name field selector. Key 1 disable limited field query. No. Yeah, there's a special. I think it's in, right? There's some in team or something like that. Shiny legacy in team. Is it that? No, that's not. No. Remove the label n from the backend pod and rerun the selection. So I'm going to remove the label. So k label pod backend and equals prod tag. What? Hold on, what? How do I remove an there is some, I mean, the tag works with taints and it works with taints and labels, so I don't know why it's not working. Oh, by removing a label named bar if it exists. Okay. Oh, so okay, so I don't have to provide the actual name. I can just do this. Yeah. Okay, and then rerun render vol pause that. So we've done this with the -a, but what was the it's a show labels. Oh, team in this. Oh god, I remember now. So it's team in this. I knew there was an in somewhere. So it's a label name in, and then you get the values in parentheses. All right. So we've learned something new. Performing rolling updates for deployment. Create a deployment name, deploy with 3 replicas. Okay, let me just delete pod and then grace period equals 0. Create a deployment name, deploys. Okay, create, deploy, image equals nginx alpine, replicas equals 3. Replicas equals 3. The pod should use engine in the name engine. The deployment uses the label tier backend. The pods should use the label app v1. Can I do L tier equals backend? Try run equals client -o YAML. Temp deploy.yaml. Okay, so k create deploy. God. Does it have a label? You can't add the label. So, oops. So, what am I doing wrong today? All right, let's remove this. And we'll apply the labels manually. So, tier backend and app deploy. Is that the no app equals v1? So that's app. Nope. Yeah, so match label app equals v1 and app equals v1. Okay. So we can deploy. Great. List deployment and ensure that the correct number of replicas are running. So we can get deploy. Yep, up to date available. And if we do pods, we have 3 pods running. Cool. Update the image to nginx latest. Okay, so set image deploy nginx equals nginx latest. All right. Verify that change has been rolled out to all replicas. So if I do k rollout status deploy. Yep, 2-3 replicas have been rolled out. So deploy has been successfully rolled out. If I do deploy describe, we can see that the image, where's the image? Where is the image? What's the image? Do grep -i image. Yep, nginx latest. Okay. Scale deployment to 5 replicas. Okay. Scale deploy. Dash replicas. Okay. Well, so, yeah. Okay. Scale deploy. Just to avoid confusion, we'll do deployment deploy because that's the name of the deployment, and then we'll do replicas. equals 5. All right, so if we do this, you can see if we do k rollout status, boom, all of them are running. Great. Have a look at deployment rollout history. So if we do k rollout history, deployment, deploy, well, there's not much because, well, we've not recorded the changes. Revert the deployment to revision 1. So k rollout undo deployment, deploy revision equals 1. Oh god. K rollout undo help. Oh, it's 2 revision. 2 revision. Okay, and ensure that the pods use the image nginx, and of course, because we used Alpine, we'll do describe this, and now we're on nginx Alpine. Cool. That was yeah, so at v1 mash labels v1. Okay, so we had the empty thing, blah blue, scale the plum to 5, blah. Okay, so create a cron job named current date that runs every minute and executes the shell command this. Watch the jobs as they are being scheduled. Okay, so k create cron job, current date, image equals, I don't know, busybox, I guess. Busybox. And then we'll do schedule equals 1, 2, 3, 4, 5. So that's every minute. And the command is going to be echo current date is date. Yep, I hope this is going to be working. Oh, God. Let me take that. Can I do this? Nope. Nope. Let me do bin sh c and then this. Yeah, hopefully this works. Okay, and then cron nope. Okay, get cj, yep. Suspend full active pods. Okay, delete deploy. Right. Okay, so k get cj. Watch the jobs as they're being scheduled. Well, identify one of the pods that ran the cron job and remember to like what? But I don't have any. Okay, cj. Okay, get cj. Current date. CJ current date. Last schedule 13 seconds. Okay, describe because it's not CJ. Yeah, but we don't have a pod name, do we? Active jobs. Why do we not have an active job? What did I miss? Create a cron job named current date that runs every minute and executes the shell command. Current date. Watch the jobs that are being scheduled. And if I wanted to pause that, run the cron job. Determine the number of successful execution. The job will keep in its history. Delete the job. Well, that's interesting. Successful job history limit 3. Okay, so that's 3. Delete the job. Identify one of the pods that ran the cron job and render the logs. The problem is it's not creating a job, and I don't know why. Oh, it is because it's every minute. You absolute dungle. Okay, so now we can essentially just do logs. Yes, and we have the current date. All right. Well. As deprecated will be removed. Yeah, you can tell that many of the, a lot of this is some of these commands are deprecated. As you can see, successful job history limit and blah blah blah, and then we'll just delete the jobs. Okay, create delete on job. Okay, so 5. We're blazing through this now. Services and networking. Routing traffic to pods from inside and outside the container. Okay, so create a deployment name my app. So okay, create deploy my app. With 2 replicas. So replicas equals 2, image equals nginx alpine. Expose the container port 80. So port 80. Okay. So that's that. Now if we do k expose deploy my app, and then we can do port 80 target port 80, and then maybe we'll call it name my app svc. All right, if we do k get svc, we should have this. Cool. Create a temporary pod using the image busy box and run wget command against the IP of the service. So that's the IP. So we'll do again we'll just do k run temp. We'll do what we did the other time. Instead of this, we'll do 3. Instead of servers, we'll do svc my app svc. Yep, because it's port 80, we are good. Change the service type so the pods can be reached from outside the cluster. So that's interesting. So we can do k edit svc my app svc, and we'll do node port instead. Okay, then we can do k svc. Yep, as you can see now we have this port. Okay, let's just change the service. Run a wget command against a service from outside the cluster, and so for that we would need the minikube IP. So that's that. And then we would have, let's echo, yeah, that's the one. That's not expose nginx, so the service is going to be my app svc. So my app svc, and now we have the correct IP address. So now we can do let's set my app svc to be equal to this. First, let's do that. Is not valid. Can I do no? No, it has to be. It has to be this. Variable name, no. Oh. Set. Can it be this? I highly doubt it, but it's not valid. What do you mean it's not valid? Actually, you know what? We'll do, we'll go to bash. No, let's exit this. No, actually, I have it in my clipboard, so we'll do we'll do export my app as VC IP. But instead of doing this, oops, nope. Instead of doing this, we'll do that. And we'll do that. And of course, it's not case kubectl. Bear with me. kubectl. All right, so now if I echo my app as VC IP, we have that. Great. So now we can do kubectl run temp hyphen image equals busybox hyphen rm hyphen restart equals never hyphen it, and then we'll do wget hyphen o hyphen, and then we'll do my app as VC IP. Presumably this should work. I hope. Yep, it does. Great. All right. Restricting access to and from a pod. Ooh, okay. So again, we'll remove the namespace thing because we can't be bothered. So we'll just do vim temp pods.yaml. What's the namespace thing? Okay, we'll just get rid of that. Cool, we'll just temp pods YAML. Great. Okay, so delete deploy. In fact, now let's just do all force. Boom. So we have the pods running. I hope. Oh god, it's using MySQL. Ugh. Okay, create the required namespace. Create the pod, copy the pod. Notice that the namespace has already been defined. Okay. Create a network policy in the YAML file. App network policy, abstract network policy .yaml. Okay, so we'll do this. Vim temp that. And we will go to Kubernetes. This, and we'll do network policy. Okay, we'll do that. All right, so copy this. We don't need egress. Do we need egress? Not sure. The network policy should allow incoming traffic from the backend to the database, but disallow incoming traffic from the front end. All right, so that's easy enough. So we don't need egress. It's actually pods. Let's open pods. Yeah. So the labels tier front end. So it's app to do. All right. So we'll go match labels. App to do. And so from no, it's hold on, no, that's not it. It's tier database. Tier database. And so it will only allow the backend it will only allow the backend to talk to it on port 3306. Am I reading this correctly? The network policy should allow incoming traffic from the backend, but doesn't allow incoming traffic. Okay. Incoming traffic to the database should only be allowed on DC and no other port. All right. So I suppose you can't do it selectively because you would have to deny all and then sort of whitelist services you want to give access to. So we'll do temp app stack network policy. All right. Incoming traffic. Let's have a look. App to do. Okay, to your database. Yeah. Oh, we have an egress. We don't need egress. Yeah, okay. Let's have a look back. To your backend. Yeah, okay. So we didn't do app to do because maybe we should have done that actually, just to make sure that it applies to the correct app. Because yeah, we should have done that actually. So let's do app to do and app to do. So for all pods in the app to do and not any other app, because you may have many other apps running. So yeah, let's just for good measure do this. Oh yeah, actually, it's the wrong namespace because if I do kget network policy, I don't have any because it's been defined in the wrong namespace. So CKAD Prep. And let's apply again. And if we do kget network policy, now we have that. Cool. All right. So that's it for services and networking. Moving on to state persistence. Defining and mounting a persistent volume. Create a persistent volume named PV with access mode read write many, source class name shared, 512 megs of storage capacity, and the host path data config. All right, so persistent volumes. I will never remember off the top of my head how to do it, so we'll do kind persistent volume. Where's it? Oh god. I missed it. That's the one. I hope. Yeah, that's the one. Okay. So great. So we can do vim temp pv.yaml. Whoops. Right. So name pv. Capacity is what's the capacity? 512 megs. So 512. I think it's M. Read write many. That's going to be shared. That's going to be host path, and the host path is going to be data config. Okay, I think we're good. Yep, we're good. So we'll apply that. If we do kget pv, yep, it's available, but it's not bound yet. Create a persistent volume claim named PVC that requests a persistent volume in step 1. The claim should request 256 megs. Ensure that the persistent volume claim is properly bound after its creation. We could do this in two different ways, but we'll do pvc.yaml. Go back to the docs and we'll do claim. I'll go back. We'll do this. Okay, we'll do that. Nope, we don't do this. We'll do that. Okay, so that's going to be called PVC. Storage class name is shared. Rewrite many. Now, this should work as is, right? So 256 MI. This should bind to. Actually, let's try it before I chat nonsense. Okay, so kget pv. As you can see, it's bound to the CKAD Prep PVC, and if we do kget PVC. It's bound to the volume called PV and blah blah blah. So they have to match. So these things like the storage class name and access modes have to match. But you can also do volume name and then say PV. And then if you want to claim to be sort of bound to a particular volume by name, then you can set the name. Mount the persistent volume claim from a new pod named app with the path var app config. The pod uses the image engine X. Check the events of the pod after starting it to ensure that the persistent volume was mounted properly. All right. Okay, mount the persistent volume. Okay, so we'll do that. We'll go back. We'll do temp and temp. What do we have? Pod. No. What was it? Backend. All right. So we have this called that, and we'll do volume. We'll do shared volume, and it's a persistent volume claim. The claim name is PVC, and then we'll mount this at var app config. The name is shared volume. Okay, so if I delete. Okay, do I have still delete pods. Delete pods. Oh, there you go. And okay, so now it's created. We can, okay, so it's running. So let's exec into the backend. Actually, the question said describe pod backend, and we should see the mounts. So var app config from shared volume, so it's properly mounted. See the volumes. Does it say anything about the volume? Condition, yeah, volumes, shared volume. Type persistent volume claim name PVC, it's not read only, and then this is the API access token, I think, for the service account. Service account. That's mounted automatically. Okay, so now let's exec into the backend pod, and I think it's var app config, right? So let's ls var app config. So we have this. That's interesting. Why do we have that? ls var app config. Data config. That's interesting. What? Okay. Okay. So maybe we're using minikube and then on me. Okay, well, let me just touch. Hello. Let me actually echo hello there onto var app config hello.config hello.text. So if I do ls var app config, I have hello.text. Yeah. So now if we do minikube SSH, so if we actually SSH into the node, and we go var data config, we should have the hello.txt. Yep, it's there. Cool. We can delete. Actually, no. Do we have anything else? So no, that was. Oh, God, go back. Okay, so that was that. Yeah, host data config. We get the PV. We saw that it was available but not claimed. Then we did the thing, and now it's bound. Blah blah blah. We created the volume mounts and the volumes, and as you can see, oh, it's bound. Okay, mount volume. Let's just do. Okay, the describe pod backend. Oh, there was nothing about volume, which is interesting, but we did check that the volume was mounted properly. Again, maybe this used to be a thing back when this was written. Stay persistent and bonus. So what do we have in bonus? Okay, shortcuts and time savers. Bash command. Sorry. Okay, so that's bash. Print a counter to console. Blah blah blah. Print the surrounding 10 lines of pod description for any existing pod with the annotation author John Doe. Okay, so it's B1. So it's grep -B10 -A10. Oh, -C. Okay. Okay, so A is for after and B. Okay, so you can do C then. Didn't know that. That's great. And finding all labels, I think it's, yeah. Again, you can just do -C. All right. So I think we're done now. We've been live for an hour and a half. I hope, I pray that the sound is okay. And so this is it. I have a long list of other resources. Let me have a look. Yep. So we've done this one. So let me mark it as done. So we have another 2 that we need to. So yeah, we have another 2 that I need to go through on video, because these 2 had bad sound. So yeah. What else? So we have 1, 2. So we have 2. Hold on. 1, 2, and 3. So we have 4 repos to do, and then we'll do the killer.sh shell. Oh, let me show you. It's killer.sh. Oh, that's not the killer.sh. Just killer.sh.com, and then we'll go and do this, the challenges for the CKAD. It doesn't have many, but you know, it's good enough. I mean, we'll just skip the first 3 and we'll do those instead. I think it has something about Helm, yeah, so that's good. I need to brush up on Helm. Oh, it's got Argo CD. Boom, that's great. This is going to be interesting. Boom. All right. Okay, so thanks for watching. Thanks for sticking around. So yeah, tomorrow hopefully I will, if I have enough time, I'll go and I'll go ahead and stream again. If you have any questions, you can leave them on the YouTube replay. Subscribe to the channel, like the videos if you like them, subscribe on Twitch or follow me on Twitch if you think I make good content. And again, if you want to see anything, if you have a good challenge for me to take, please send them over. I'd be happy to oblige. So have a good rest of the day or night, depending on where you are. And I'll see you hopefully next time. So cheers.